All right, this one was just basic addition. That's all it was. All right. Everyone had it down. I don't know if you did it on your own or maybe saw somebody in your groups, but you know if you struggled with this one or not. And this is just a basic one right here. AB plus BC is equal to ED plus DC. Addition. Also, too, and yeah, I am getting picky. You write add on the quiz next week. It's not going to be accepted. It's called addition. All right, not add, addition. All right. Just like number 3 is called substitution and not sub. Because I don't know if you're talking about subtraction or substitution. So. All right. Pretty basic. You'll get another opportunity later on in the notes to do another review proof for me. Any questions here? All right, as you see, I added up another sheet of paper, and it's pink this time instead of yellow. The reason why it's pink and not yellow is because the pink now deals with all angles. Now, I'm going to give you guys some facts today and Monday regarding angles. And there's only one today, and it's called all right angles are congruent. I'm just going to go ahead and set up number 1 for me with whatever markings you think you need to go on the diagram and statements. That's it. Don't try to do it. I'm not asking you to do it. I'm asking you to set it up like we usually do. Read the givens, mark your diagram with whatever markings you think are appropriate, and then throw your givens in statement number 1. Bless you. Okay, it says angle ACB is a right angle, so hopefully we have the right angle symbol at ACB. All right, we should have an angle, right angle symbol there. That just says it's a right angle. All right, somebody right now here, let's remind me, what is this symbol mean right there? What's the name of it, and what's it do for us? All right, what's that symbol again? We got it here. 15, here we go. Alexi, remember what's that symbol first? It means perpendicular, and then when 2 segments are perpendicular, what magically happens? Oh boy. Oh boy. When 2 lines are perpendicular, what happens there? What happens? 20. Brendan? Makes a right angle there. Okay, makes a right angle. So on our diagram where CD and AB meet, I should also have a right angle symbol. And you can put them in both places right next to each other. Okay, so when they meet, are we good there? Perpendicular? Everybody, yes? When they meet, they form right angles. All right, so my whole diagram is complete. Now look at the proof statement. ACB. Well, what did we already say ACB was? What's there? It's a right angle. Why is that congruent to ADC? And what did we just put at ADC? A right angle. So shouldn't they be congruent? Because what do right angles measure up to? 90 degrees. So making sense in our minds, okay, that makes sense. They have to be congruent because they're both right angles and they measure 90. But I don't want that written in the statement's reasons. I want certain things written down. And this is why I've given you the new one. We're going to use this to say they're congruent. All right angles are congruent, but not in the next step. If you want to tell me right angles are congruent, you must have both right angles written here in the statements. I don't care how beautiful your diagram is. I don't grade this. I want both right angles written in here. And how many right angles do I only have right now? One. You did not tell me the other one was a right angle yet. You marked it on your diagram, but I don't care about your diagram. I want it written in here before you say they're congruent. So I already have, take a look, I already have ACB. That's already in there. Now you need to tell me ADC is a right angle, which we know is true, but I need to put it in the statements. So next, angle ADC is a right angle. And how do I know it was a right angle? Why did I mark it on my diagram as a right angle? There was something here in this proof that said you better put a right angle symbol there. And we have used this reason before, but I know it's been a few days, but explain to me why that's a right angle. What up here told us that? Here we go, 2. Bailey? How did I know ADC was a right angle? Why did I put that mark in there?
Because CD is perpendicular.
2?
AB.
Okay, and what do perpendicular lines do? Form right angles. So perpendicular lines form right angles. And this will be the reason every time we say an angle is a right angle. Perpendicular lines form right angles. Now do I have both right angles in the statements? Now you can tell me those two are congruent. All right, but they have to be listed in the statements first before you say they're equal to each other. Angle ACB is now congruent to angle ADC. And here's our new reason here today. Anytime you want to tell me two right angles are congruent, I use the reason all right angles are congruent. But again, everyone with me here, if you want to say all right angles are congruent, both right angles need to be listed as right angles in the statements. I don't care about your diagram. It's got to be in your statements that they're right angles. Anything you want to hear before we go to a more complex one here, number 2? All right, I want to mash both the yellow and the new one here, all right angles together in one proof now. That's what I'm going to do. We're going to use the yellow and the new all right angles. All right, do your thing. Mark it. Write the givens in. Do your thing. We got perpendicular lines, which we just talked about. So hopefully I see some right angle symbols on your diagram. And I should see a pair of arc marks for ABC and FGE. Make sure we have everything marked correctly where it needs to be. What's the angles? It's not those. Find where those are. Those aren't. That's not ABC. That's ACB. All the letters. That's angle CAB, right? I need ABC, all the letters. All the letters. Okay, here we go. Everyone's seems like we're at the first step here. Everyone, we should have a right angle where AB and BD meet right here. And we should have a right angle where FG and DG meet right here. So we should all have right angle symbols right there. All right, when you guys find these angles, you got to follow the order of the letters. A, B, C. I traced an angle out there. A, B, C right here. Congruent to F, G, E. F, G, E. Remember, the middle one will tell you where the vertex is. I guess I'll put it right there. All right, so that's what I have. Everyone's good on the markings. I got to take it slow here. Everyone's good on the markings. Now let's go to the proof statement. Take a peek at the proof statement. Do not mark it, right? We don't never mark our proof statement. DBC, can you please find that angle for me? DBC. Everyone sees where it is. Don't do this. This is just to help some of you guys that can't find it. There it is, right there. There's DBC. That angle, I need to prove congruent to DGE. Everyone, please find that angle. DGE, which is that one right there. All right, so I need your help. I need to get those two congruent somehow. I already have some right angles and the congruent angles. So how can I use those? Don't make up your own stuff here. Let's use something I've already used. Can we at least eliminate halves of equal quantities? I don't see bisector or midpoint. Don't even start sniffing that. That's out. All right, so here's what I'm left with right here. Addition and subtraction, basically. All right, we don't have anything else for you yet anyway. Addition and subtraction. So is there any of those two maybe I can use on this diagram to get to those two angles? Bigger, smaller, here we go. Anything I can use here? Anybody want to take a shot in the dark here or are pretty confident that you know what we're going to use here?
Subtraction.
This is going to be subtraction. Why is it going to be subtraction? Ready? Take the triangle on the left right now. Take the triangle on the left, please. Everyone sees the right angle we marked? Everyone sees the right angle we marked, yes? Take away the angle that was congruent. Take it away. What's left? The angle I need, isn't it? I take the right angle minus this one here that I just marked. I have the angle that I need. Go over here. Take the right angle, subtract out the angle that was given. What's left? The angle I need. Time out. It's subtraction. Great. How many quantities do I need to subtract? How many? 2. As I look through the givens, I only see 1. So we need to write the other one down. What am I subtracting with these two angles here, ABC and FGE? What else is involved in the subtraction we just talked about? Yes, these angles and also the... What's involved here? You don't need to name them, just ABC and FGE along with... What am I subtracting with these? The right angles. So they need to be congruent before I subtract. Because look, it's the right angle minus the given. The right angle minus the given will give us these. But I only have these. You need to tell me now the right angles are congruent before we subtract. Before I say right angles are congruent. Did I list any right angles yet? Did I list any? Nope, so that's going to be number 2. Tell me what the right angles are. Name them for me. Name them. Let's start out. 15. Alexi, redemption time. Name a right angle. AB, a right angle. ABD, angle ABD is a right angle. And how about another one for me? Angle ABD, and what's the other one? FGD are right angles. Same, if you haven't seen it yet, it's the same darn reason every time I say two angles are right angles. It's the same reason every time. How do I know they're right angles? 22. Simon, how do I know they're right angles?
Because of the definition of perpendicular.
That's fine. All right, I write perpendicular lines form right angles, but I would not mark you off if you wrote definition of perpendicular lines. So you told me they're right angles. Now what do I want to say about them before I subtract? You told me they're right angles. What do I still need to tell you in step 3 about them before I subtract? 15, going back to you, Alexi. They're already right angles, so now I need to tell you they are. This is a subtraction proof, right? How many quantities do you need to subtract? I only have one. So what do I now need to do about the right angles? No, well, I can't subtract unless I have two pairs of equals. Of equals. We already have one pair, so what do I need to tell you about the right angles? What's the big topic today? If two angles are right angles, they have to be what? Equal. So what do I need to tell you about ABD and FGD? They are congruent to each other. Why are they equal? Use what I've given you today. 16, Bryson.
Because all right angles are congruent.
Right up there. All right angles are congruent. And yes, this is going to be your longest proof of the year here. How many equal quantities do I have now listed? 2. Now I can subtract. So here comes your subtraction step. I need somebody to tell me what angles you're subtracting, though. Appropriate. What angles am I subtracting up here? 13. Where am I going for 13 here? Jonathan? Whoa. That's the smaller one, so I don't want to start with that. Yep, minus. Now you can do it. Yep, and then how about on the other side? Yep, minus. There we go. There's our subtraction. And then we always end it the same way if we subtract or add right next, immediate next step, substitution with its replacements. Whew. It was subtraction. How many pairs do you need to subtract again? 2. I only had given you 1. And unlike the last couple days, the second one wasn't reflexive. The second one was the right angles, which you needed to tell me were congruent before subtracting. All right, I'm going to keep walking around again, just like I did at the beginning of class today. This is a review proof, number 3, a review proof. Okay, this is nothing new I need to show you. This is a review. And as you guys start reading, what do you automatically see? Okay, so there shouldn't be subtraction, addition, right angles. It should end how, everyone? How should this proof end? Halves of equal quantities, but it's not going to be 2 steps. You need a step in between. Okay, so I should see no right angles here. No addition, no subtraction. We already said it's going to end with halves of equal quantities. Just a matter of what do I put in the middle. It's not going to be 2 steps.
here, they're separate from each other. Remember, before you use this, you need to tell me what you're taking half of. So you need those half statements in there. Okay, now that's how you end the proof. Okay, so that should be why 1 and 2 are equal. Why are you taking half? Because of, it said bisect, so definition of bisect. Okay, and if you put the angle series with these here, so I know they're not lines. That's not how, we don't end it that way. We end it this way. So that's why 1 and 2 should be equal at the end. I don't know why we need that in there. Okay, because that was already given.
Yeah.
Very good, that's keep, you're fine. Now end it now. Then what do we always need in every half of equal quantities? A pair that's equal, and you showing me you're taking half of that. Correct. So I need half of this angle equals, call it a name. Half of this angle, call it a name. Probably 1 and 2, because that's what we're trying to prove. And then I go from there. This is how it ends. This is how it ends. Okay? It doesn't end with substitution, it ends with halves of equal quantities are equal. And if you write that on a quiz or test, I'm not going to accept that. I accept the full thing only. So over here, how do you know you're taking half of those two angles? What told you in the givens? So definition of bisect. Okay, let's hear you go.
If you take half an angle, you can't draw a line segment from half an angle, right? Look up here. If you look at the diagram, if you take half of EAB, you either get angle 1 or you get GAB. Which one am I concerned with? 1, so I'm going to call that angle 1. Okay? Right? You can't take half an angle and get a line segment back. I'm going to call that angle 1.
All right. The same thing goes for the next one.
All right, here we go. Got to move on here. Okay, halves of equal halves of equal quantities. Nothing else should be showing up in your proof. All right, we had a few people end with substitution. It ends. The proof is done. This right here, 1 congruent to 2, is going to be because of halves of equal quantities are equal. The middle step you needed was what you're taking half of. So each of these angles that are congruent, EAB and ABC, or FBC, sorry, FBC, you needed to take a half of. And call it probably 1 and 2. All right, I don't want to call it GAB or HBC. It's not involved in the proof. So angle 1, angle 2, that's definition of bisects, not halves of equal quantities. And then you finish it off with 1 congruent to 2, halves of equal quantities are equal. All right, we're good. That's how I finish it off. My hope is you start seeing that all these proofs are done the same way every single time. It's just a matter of subtraction, addition, halves of equal quantities. Right? They're done the same way every single time. All right, I need to throw some algebra here at you before we leave, because we've been doing proofs. Before we get into it, hey, please lock in here. I know I said given, but now take a look. I didn't say prove, did I? I said find. So this is not a statement's reasons. This is just use some algebra and find these measures of the angles for me. All right, so it is given that these two are perpendicular, so hopefully you can mark something on your diagram right now in the appropriate spots. Line RST is perpendicular to ray SQ. Okay, so hopefully we can have some markings here somewhere. Using those two, what are you marking on your diagram? Let me know. If RST is perpendicular to SQ, what are we marking on the diagram? 20. Brendan, what are you marking? Love it. Good man. And it also says that angle RSU measures 89 degrees. Got it. Find. I don't need statements, reasons. Here we go. Find the measure of angle RSQ. So if you look at your diagram, ready? Angle RSQ. 12. What do we see there, Finley? Yep. 90, right? But now, hey, I added a little piece here in bold. Justify your answer. Tell me the why. All right, why is it 90 degrees? In your best explanation, why is it 90 degrees? 17, Dylan. I don't want because the box is there. Tell me why I put it there. Perpendicular lines form right angles. There you go. Basically, what would I put in the reasons column here, right? All right, move on. QST. What's the measure of QST in this diagram? QST? 14. Stephanie, QST? 90 degrees as well. And the reason, again, I put the right angle symbol there was because perpendicular lines form right angles. Again, somebody earlier said definition of perpendicular. I'm fine with that too. One more angle. Got to work for this one, the missing one. TSU. Angle TSU. Sorry, I know you don't have your calculators with you for that one. TSU, not 90, because it didn't say it was perpendicular. You're going to do this one, Bryson?
Yeah, it's 91.
It is 91. Can you back yourself up now? Why? In your own words. How'd you know that was 91?
Because RST is 180 degrees.
Yep.
And 180 minus 89 is 91.
So what'd you know about these two angles then? I want you to start using vocab now if they added up to 180. They were supplementary. Good. All right. Supplementary. You can write supplementary angles add to 180. Something. I'm not looking for a magic wording here. Something that tells me why the heck did you write down 91? Other than I have good eyesight and I could see my partner's paper. All right. Something that tells me why you got 91. Just a warning as you guys start the assignment now. There are review proofs in there. Don't be surprised if you might see an addition, subtraction, halves of equal quantities. All right, it is not all right angles here. And if it says find, just find it. No proof needed.